Hi, today I'm going to teach you about biochemistry and most of everything you need to know for the AP exam. To start, we actually have to know what biochemistry is. Biochemistry is the science of the atoms and molecules in living organisms. And what this allows us to know is how the food in our bodies, the food that we eat, makes up our bodies. So it makes up our tissues, our bones, our hair. Everything comes from what you eat. And some way we can actually use biochemistry is, let's say you take cholesterol pills. What the pills actually do is they inhibit an enzyme that helps in the making of cholesterol. So this was actually developed by researchers to study the way the enzyme worked. So they could create a pill that didn't inhibit other enzymes that would be harmful for us. Moving on to atoms. Atoms is a fairly easy concept, so it's mostly review, but I'll still go through it. Atoms, they have the neutrons and the protons right here in the nucleus, and the electrons outside in different electron levels or electron shells. Electrons have a negative charge, protons have positive charge, neutrons have no charge. So here in the top left, when you're looking at a periodic table, you'll know the number of electrons. 2 here, 8 here, and 1 here. The reason that they're like this is because they can only have 2 in the first level, 8 in the subsequent levels. So if it has 11, it has 2 in the first level, 8 in the second level, and 1 in the third. The last level is called the valence shell. And that's basically the last level of the electrons. Here it will have 1 valence electron. So let's say they have this electron, it will have 8 valence electrons, and that will mean it will have a full valence shell. Now, in the bottom, you will see the atomic weight. This is basically the sum of the number of protons and neutrons in the element. And the reason why we can know the number of protons and neutrons is because elements are neutral in their charge. That means it will have 11 protons. So if it has 23 as its weight, 11 plus 12 neutrons give you 23. This example is sodium. And the reason why I use sodium is because sodium is also one of the components that make up our table salt. And the way that it makes up table salt is sodium actually performs an ionic bond, which one element gives its electron to another element. And in this case, it's chloride. Sodium has 1 in its valence shell, and elements want to get a full valence shell. So it gives it off to chloride that has 7. And in this case, we get table salt. Sodium in itself is highly reactive to water and it can blow up. So it's not safe for us to eat. But if it forms a bond with chloride, we get table salt, which is actually safe for us to eat. Now, the second type of bond is called a covalent bond. In this case, the example is CO2. We have a carbon atom here and the electrons, the oxygen atoms. Each of them have 6, while the carbon only has 4. What they do is they share, carbon shares off its electrons with the oxygen to make a covalent bond. They share it evenly most of the time, and they form another type of bond. It's strong like an ionic bond. The third bond, it's called a hydrogen bond. It mostly occurs between water molecules, but can also occur with hydrogen and nitrogen and other electronegative particles. What this means is hydrogen, it's not electronegative. What this means, it doesn't pull on its electrons, while oxygen is. So oxygen, what it does is it pulls on the electrons, it wants them from the hydrogen. And the hydrogen, what this does, it gives it a full shell of 8. It's a covalent bond, but they spend most of the time around the oxygen. And this creates a different type of charge on one side than the other. In this side, it's a positive charge near the hydrogen. On the oxygen, it's mostly negative because it has more electrons. What happens here is the water molecules, they form hydrogen bonds between each other. They may get several different properties like high specific heat, and it allows them to perform cohesion and adhesion, which helps roots send the water up to the leaves in a plant.